Hi everyone, my name's Klaus Merman. I'm the Head of Partnership Solutions Engineering here at Beacon, and I'm going to show you how we can integrate with our new partners over at DataRobot to build a machine learning based trading strategy using AutoML and then running market predictions using Beacon's WIMP compute infrastructure. So what are we doing exactly? Well, let's just say I'm going to ignore the advice of a good friend of mine and predict some prices, namely the CME crack spread between crude and heating oil. Let's look at the steps involved. So here's a little overview diagram of the workflow steps. Let's start with the Beacon platform box at the bottom. So I will show you how we can use our CME plugin to fetch some intraday prices for crude oil and heating oil. And then we'll basically just export those, do some data prep, break them into sort of 5-minute buckets, calculate some weighted average prices for those, and see if we can build a model that predicts whether the crack spread will widen or contract over the next 5-minute period. And then I'll hand over to my colleague Peter Simon, who's head of the financial markets practice at DataRobot. He's going to walk you through ingesting the data into DataRobot, how he does the training and testing of the models, use AutoML to generate a whole load of models. He'll then pick the most suitable one, and we will package it up and deploy it into Beacon. And then inside of Beacon, we run a DataRobot portable prediction server, which is basically just a container that runs on our WIMP compute engine, and that loads the model and effectively lets us access it via a REST API. And then what we can do is we can fire some new data at that model and use it to generate predictions. Once we have the predictions, we can load them into a backtesting tool just in a simple Jupyter notebook, and we'll see how our trading model does. Let's move over to one of our Beacon demo domains, and we'll go to the App Store and take a look at how we get some CME data for this model. So we will basically install this plugin in our domain, and once it's installed, if we go over to the Beacon IDE, you'll see that we get a new repo available inside the domain with a whole load of sample code for CME. And inside of the plugin, there are some examples as to how you can fetch intraday data, but we've also built some useful wizards so that you can kind of configure jobs to run daily and even sort of backfill the data. So if I open up one of these wizards and just hit F9 on that, and so this wizard is basically a template that lets you create a bob job. So for example, I can pick, crude oil, heating oil, maybe I want RBOB as well. And what this does is effectively generate a YAML file, which I can then export, check in the code, and it will create a bob job for me. You might have noticed there's also a backfill job as well. There's another wizard for that, and you can use that to effectively backfill the historical time series going back as far as you want. So let's have a quick look in Bob at that job. So in here I have an intraday CME job, and if I look at the log for that, it's really just going to fetch every available contract and all the intraday market data, for various futures contracts and spreads and everything you want. And that gets loaded into a time series. So CLN3, I think that's June 23. So for example, here we're pulling in, you can see, let's open up one of these, effectively just a single trade record for that timestamp with some basic data around the trade price and the trade quantity. All right, so let's switch back to Beacon Plot. Now that we've got the data, we can have a quick look at what the time series looks like. So you can see we've got a series for crude oil and heating oil up at the top, and then on the right-hand axis, we've basically just plotted the spread that we're going to try and predict. Before we pass it over to DataRobot, they suggested that we kind of package it up and do some data pre-processing. And we chose to do this on the Beacon side because later on, when we actually feed some new data into the model, we're going to want to be able to format it in the same way that it was input into the DataRobot model. So if we go back over into the IDE, you can see we've got a directory here with a bunch of functions that we wrote to kind of process the data, and later on we'll come back and look at some of the prediction and backtesting pieces. But essentially this calculate inputs script is kind of calling this crack spread stats function, and what that's doing is it's essentially kind of bucketing all of the trades into 5-minute buckets and kind of dumping the data back out into a time series that we can then export over to DataRobot. So you'll see, for example, we've got like a open, high, low, close for each 5-minute time period, and things like trade counts and trade volume, and the volume weighted average price for that period, and things like that. So all of these will be dimensions that go into the model. And so what we do is we effectively just give Peter a bunch of CSV files that have all of this data in it, and I'll hand over to him now to walk you through how we do the model training.
Now we've got the data ready from Beacon, we can ingest this data into DataRobot and start building machine learning models. Now, typically our users would do this using our Python or R APIs, which provide a lot of flexibility and can be used interchangeably with the DataRobot graphical interface. However, just to show what exactly is going on, we'll do this in the graphical interface. First thing I do is very simply ingest the data from our AI catalog. I can also ingest it directly to the platform, but typically we would put the data connection into the AI catalog, select the data we want to build a project from, and then click the Create Project button. At this point, DataRobot will then ingest the data. It will do some exploratory analysis, and it'll then give us the opportunity to set up the machine learning modeling task in a way that we want. First thing we need to do is quite simply tell DataRobot what's the target variable that we want to predict. We can either type this into our box up here, or indeed I could scroll down and select it. I can now scroll down into my data and have a look, for instance, at the distribution of different variables, and have a look here. I can see some univariate summaries of these variables. Another thing that I want to do, because this is a financial markets application, is quite simply set up time-aware modeling. So set up backtesting to ensure that models are being trained on earlier observations and validated on later observations. We have a variety of modes in which we can do this. Time series forecasting, for instance, would generate various derived features from the data to incorporate lags, moving averages, and so on. In our case here, we're going to have a look at automated machine learning, so we're simply going to make the assumption that each individual observation is independent. I can now set up in more detail the backtesting strategy that I want to do, and I can configure each individual backtest here. Or in this case, I'm just going to say I want 3 backtests, and I'm going to go with DataRobot's default settings. So if I hit Save Changes, DataRobot will show me partitioning of my data. And at this point, I can now go ahead and click the Start button and start the process of training machine learning models. What I'll do up here is I'll take my number of workers up to 20. Each worker can train 1 machine learning model at a time. So now I can train 20 machine learning models concurrently. What DataRobot's doing at this point is analyzing the data in a bit more detail to understand what are actually the appropriate machine learning pipelines that can be applied to the data. And as a next step, DataRobot will then go ahead and generate a number of what we call blueprints. Now, each blueprint is a combination of 1 or more open source machine learning models. DataRobot, first of all, will put together a repository of blueprints, and if we scroll through this repository, we can see here these small icons in the left-hand corner represent the different open source machine learning libraries that they're based on. So these little DataRobot icons here are our own forks of open source machine learning libraries. As I scroll through, I can see there's a number of different libraries, techniques, and so on. XGBoost may well be familiar to a number of our listeners. Likewise, Keras here. So we have a variety of deep learning models available in the platform as well. Just to illustrate a very simple blueprint, we'll have a look at this logistic regression here. And in this case, we have one machine learning algorithm and the data pre-processing steps that we need for it. So we have logistic regression, statistical learning algorithm taken out of CD classifier, and then we have the steps needed to prepare the data for this particular algorithm. So one hot encoding, dummy variable encoding for the categoricals that we have. For numeric data, we deal with missing values, and then we standardize the data. DataRobot can also ingest a large variety of other data types, including images, text, and also geographic locations. Once DataRobot's compiled the repository of possible blueprints, pipelines that can be applied to the problem, DataRobot will then go ahead and also prepare actual machine learning models, train these models on the data that we have, and rank these models by their out of sample performance. So we can see here they have the average score across all back tests. Now I can have a look at these. I can rank these models on a variety of different metrics. For instance, if I only care about the top X% of predictions, I can rank them on here, or I can have a look at the area under the curve and so on. As we scroll down, the models get less performant, and we can see there's a sort of variety of models here. We hit a logistic regression fairly early. We also hit the majority class and naive baseline fairly early. But so now I've got a bunch of machine learning models. I have one which is recommended and prepared for deployment, which we'll come back to in a second. We can now answer a number of questions regarding these models by digging into them a bit more deeply. So first of all, we can see, okay, this is an XGBoost blueprint. You can see it's a little more complex. We're doing partial PCA, then k-means clustering, and then taking all of that, combining it with other variables and ingesting that into an XGBoost classifier, which then makes the predictions. The first question I probably want to answer is simply, is the model any good? I have a variety of tools available for this, such as, for instance, a lift chart, an ROC curve. On the ROC curve, I can do various things, such as changing the threshold above which I'd count my prediction as being a positive. So if I think, for instance, that I want to call it something like 0.5 here, looking at the distribution of my two classes, I can change the threshold and then see how my confusion matrix over on the right changes. And I can then also have a look at other metrics for this matrix here. I can have a look at the accuracy of my predictions over time, see if there's any sort of temporal patterns in how my predictions are getting on. And I can also have a look at the stability of my error metric over the different back tests. In this case, for instance, because I had a sneak peek at it earlier, I can see that all three of my back tests are actually more or less stable, which is quite encouraging. You can see here that the holdout is blanked out. It's blanked out because I haven't yet unlocked it, because I only want to unlock the holdout once I've actually selected my model. I can also answer a few other questions, such as, what is driving the model? Here I can see what are my important variables, and I can have a look at the sensitivity of my predictions with respect to my important variables. So, what percentage of my predictions are positive for different values of, for instance, my closing price of heating oil. I can look through the different variables. I can also overlay other information on it to take account of the fact that other things generally are not equal. And finally, I can get explanations for each individual prediction out of DataRobot. Looking at a few examples here, I can then see, okay, these are the most impactful variables, and this is the direction and magnitude in which they're impacting. Once I'm happy with the model that I've chosen, I can then I can deploy the model. We can see here that we've already got a model prepared for deployment. This is our best model up the top. So if we now go to this model, then I can simply take my model package out of here and then pass it back to Beacon. Package is just being generated here, and once that package has been generated, it'll download, and I can then plug it in to Beacon and carry on from here.
Thanks, Peter. So let's come back to our workflow that we started the webinar with. And what we've done now is, Peter's trained, tested the models in DataRobot. Now we need to download them and bring them back into Beacon so that we can deploy them and run them on WIMP. So how do we do that? Well, the first step is, effectively we've downloaded the model from the DataRobot website, and we've set up a simple file here that just defines the different models, and we'll be using this one in the demo. But all we've done is put them in the shared directory on the file system so that we can pick it up and run it from there. So in order to run the prediction server, we need to set up a script which will effectively spin up a WIMP server engine with the DataRobot Docker image and then a bunch of inputs around, say please start my prediction server with this model. And this is the command that the DataRobot prediction server runs. And what does that actually look like? Well, to make it easier to spin up, we've got like a little wrapper job which lets you run it from Bob, and all that's doing is specifying where and how to launch the server. So the job's kind of in here. I've already got it running. It's just printed out some simple logs to show that it's happy. If I go over to my WIMP dashboard, you can see I've set up a data science pool here with running a couple of machines, and here's my job running the prediction server. So you can see that's all set up and ready to accept some inputs. So I can test that's running. I've got a little script here, get single prediction. So this will basically just take one row of data, sort of 1 5-minute chunk of data from a particular point in time from the data that we've got loaded in the time series. And if I run this, you can see down here it's got a prediction back. So it's given me a value to say, here's the here it is, that's the number I'm looking for, 0.56. so 56% confident that the spread will go down in the next 5-minute period. So long story short, that prediction service is running. In fact, if I go in here and look at the engine log, I should see that query in here. So there it is. There's the same values that you can see in there. Right, we are going to, next thing we need to do, now we have a script. I'll switch to this window here. So this is a script that will then effectively run through a lot of months worth of historical data, so we can configure the period that we want to look at. We can say, let's run this for the historical intraday trade data for the month of April, and let's get the spread data for these 3 futures contracts, right? So we'll basically pre-process all the data for those months, get predictions for every single 5-minute period in all of those months, and then we'll also sort of run a simple trading strategy against those once we've got the predictions, right? And what that means is to say, is really simple example strategy. If the prediction is the spread will go up, we'll buy 100 lots, otherwise we'll sell, and just end it at the end of that period. So this script is really kind of pre-processing all of the data, getting predictions from the prediction server, and then running a trading strategy all in one. So as you can see, the output for that is down here. I already ran it. It takes a little while to run, but effectively it's running on WIMP as well. As you can see, I took a screenshot earlier. This is what it looked like when it was running all the predictions. It fired up a whole load of elastic compute nodes to parallelize all of those calculations. Okay, so now our compute job has finished running on WIMP. We can take a look at the output of, say, the predictions that we've received back from the model. So if we switch over to our time series viewer Beacon browser, then I can open up one of these rows, and we can see these are all the inputs. So the crude oil kind of stats and heating oil, the actual spread, and then a prediction of what will happen in the next 5-minute period. So as you can see here, the probability of it going up is rated by the model at 0.58, or 58% chance it thinks that the spread will widen in the next period. So that's what the data looks like. So how do we evaluate it? Well, we'll switch over to this notebook that we put together. We'll skip through the top part pretty quickly. It's imports, specifying the time range. This one is saying let's look at the month of April's intraday data, and we want to evaluate the predictions for the contracts for May, June, and July. We have a couple of different trading strategies, like a really simple one that either buys or sells a fixed amount, and another one that is a little bit more picky about the prediction accuracy of the model. This generate data section, that's what we ran in the IDE already. So we'll go straight through to the evaluation, right? And the first thing that we looked at was basically, the green line here is the actual spread, and the red up and down is basically if the model is saying, I think the spread's going to go up or down over that period, right? So they're simply giving you a view of what the model is actually predicting. If we look at that in a little bit more detail, we can actually sort of evaluate whether the model was correct. So if you can see, like, the green triangles point up, if the model was correct, then you get a green arrow, and if it's incorrect, it's red. So as you can see, it looks kind of 50-50 in here in terms of accuracy. We had a quick look to see whether it was going to be more accurate if the spread change was greater, like it was more likely to be correct. But again, it doesn't seem to make that much difference. This one's kind of interesting because it looks at the cumulative accuracy over time of the model, and you can see that, over these couple of days that we're looking at, just doing the plotting over 2 days, not the whole month, because the plots are easier to read. But the final accuracy of the model there was 50.662%, and that's pretty much close to where casinos operate a roulette table. Let's carry on and look at evaluating the trades that came out. So I'll just keep scrolling through here till we get to the next chart. So this is like the basic trading strategy. You can see here's just like a reference plot of the actual spread again. The red is just a plot of the trade, so we're either buying or selling based on the prediction at that point in time. And then the actual P&L over a couple of days there actually looks pretty decent. So that's quite nice. Let's move on through the kind of daily profits analysis. What are we doing here? So this is just a distribution of the P&L over the 2-day or 3-day period of the model, and what we're doing is looking at different contract months. So the top one is K, May, M is June, N is July. We're looking at how the model performs for different months, for different contracts that it wasn't actually trained on. I guess there's not much to look at there because we're only looking at 3 days worth of historical data, but we could plot a lot more and get a nicer distribution. Okay, so that's the trading model analytics over. So let's just go back to the start. So actually what we looked at the end there was kind of monitoring the three different models as well. So yes, you can also do that in Beacon if you want to build it yourself. Obviously you can do it in DataRobot too. And then we get back into sort of finishing the loop of saying, well, maybe at some point then, if the model isn't performing anymore, we might trigger a remote procedure call to maybe say rerun the model training now, and that kind of completes the loop. So that's how we integrate Beacon with DataRobot. What we'll do is we'll put some sample code onto Beacon Lab, which you can get from the App Store, and then you can take a look a little bit more in detail as to how we got this running. So we'll put some examples of how to run the prediction server and to spin it up and to push some requests in and get prediction responses. Okay, brilliant. So thanks for watching, and we'll see you soon.